So we have these learning goals, okay? So take a second to read through them. Those are our goals for our lesson. Okay, moving on. So angles. An angle is formed by two rays with a common endpoint. This common endpoint is called a vertex. The rays are called sides. We name an angle using 3 points or letters. The middle point must always represent the vertex. We use a single letter if there's only one angle located at the vertex. When referring to the measure of an angle, we use a lowercase m. For example, the measure of angle ABC equals 60 degrees. The interior of an angle is the region containing all the points between the two sides of the angle. The exterior of an angle is the region containing all the points on the outside of an angle. So in our picture, our vertex is point A. Our sides are rays AB and AC. And the names, so we can call this angle A, angle BAC, angle CAB, or we can refer to it as the number inside. So sometimes we can call that just angle 1 if there's a number there. So naming angles. How many angles are in the diagram? Well, in this picture we have 1 angle, 2 angle, 3 angles. What are the two names for angle 1? Well, we could call this angle JMK or angle KMJ, as long as the M is in the middle. What are other names for angle KML? So we could call that angle LMK, or just by the number, angle 2. Would it be correct to name any of the angles angle M? Well, as I said above, we can only use one letter if the angle is a single angle. So no, only one letter is allowed when there is a single angle. This picture has 3 angles, so not allowed. Finding the measures of angles. So we want to find angle AOB. So this is measure 1 at 55 and measure 2 at 180. So the measure of angle AOB is the absolute value of 55 minus 180, which is 125 degrees. That's if we use this outside one. If you know how to read a protractor, we can also use these numbers on the inside. So we can go from 0 to 125, just like that. Flip the page. We're on classifying angles. So angles are acute if they're from 0 to 90 degrees, right if they're exactly 90, obtuse if they're from 90 to 180, and a straight angle is exactly 180, or sometimes we'll just call that a line. So a straight angle and a line are the same. So we have a measure and classify angles. So for the first one, we have measure LKN. So we have LKN. If we use this inside, we are going from 0 to 145. So this is 145 degrees. That's obtuse. JKL. That's from 90 to 35. 90 minus 35. That's 55 degrees. That's acute. And JKNs, that's from 0 to 90. So that's exactly 90. That's a right angle. Two angles that are congruent have the same measure. They are marked with an arc or a congruence arc. We use a congruent symbol to denote angles when they're congruent. Equal angle measures means you have congruent angles. So if measure of angle G is 42 degrees, measure of angle S is 42 degrees. Therefore, angle G is congruent to angle S. We know that if the measures are equal, the angles have to be equal. So equal sign has to do with measures. Congruent sign has to do with angles. In this diagram, it's important to note the amount of arcs. So one arc symbol is congruent to itself. So WBM is congruent to angle YEM. Two arcs are congruent to each other, so angle MDC is congruent to angle ADE, so right here. And YAC, that's the three arcs, is congruent to, if we add an extra point, let's call this F, that's congruent to WCF. An angle bisector. So a ray that divides an angle into two congruent angles. So angle Y is a bisector of angle XAZ. So angle XAY is congruent to angle YAZ. So let's just mark that on our picture. So marked. So we're going to be solving using congruent angles. With justification. So angle LM bisects angle JLN. And then, so if we have two congruent angles, we know angle JLM is congruent to angle NLM, and that's from angle bisector. Then we know that the measures have to be equal. That's from congruent angles. Then we can go ahead and plug in our measures. So 6x plus 2 equals 9x minus 10. So that's substitution. Then solve. So we're going to subtract 6x from both sides. So that's subtraction. So we get 2 equals 3x minus 10. Add 10 to both sides. So we get 12 equals 3x. Divide by 3. We get x equals 4. Is it reasonable? Yes. How do we know it's reasonable? So we know it's reasonable because we can plug in. 6 times 4 plus 2 gives us 26. 9 times 4 minus 10 gives us 26. That's a reasonable answer. And then to answer our question up here, the measure of JLN, 26 plus 26 equals 52. Okay, in this picture, we know that KLB is 26 degrees, BLM is 60 degrees, 26 plus 60, that gives us 86 degrees as our missing measure. On this other one, we know MLU is 20 degrees, MLK is 110 degrees, so 110 minus 20 degrees gives us 90 degrees for our missing measures. So what we just did in that problem, in those two unknown measures, is we used the angle addition postulate. So what the angle addition postulate means is if we have point B is in the interior of angle AOC, then the measure of angle AOB plus the measure of angle COB equals the measure of angle AOC. Okay, last problem. Flip the page. If the measure of angle RQT is 155, then we know we want to find what our two other missing measures are. So we are using the angle addition postulate. So we know that measure of angle RQS plus measure of angle TQS equals measure of angle RQT. Reason is angle addition postulate. Now we're substituting in, so 4x minus 20 plus 3x plus 14 equals 155, so that was substitution. Now we combine like terms, 7x minus 6 equals 155. Add 6 to both sides. So you get 7x equals 161, that was addition. Then we divide, x equals 23. Is it reasonable? Well, let's plug in and find out. Measure of angle RQS is 4 times 23 minus 20, and that's 72 degrees. Measure of angle TQS is 3 times 23 plus 14, that's 83. Together, if we add those angles up, we get 155. So yes, it's reasonable. Okay, finished off the note video by filling these two questions in. So look over your goals from the beginning. What do you feel you know at this point in your learning? What are you unsure at this point of your learning? And what questions do you have for me?